to look at problem number 9. So we're doing the back of the review sheet. And we're doing problem number 9. So as always, we're going to write our given and find. So it says a 500 kilogram pig, so that's my mass. Is standing at the top of a muddy hill on a rainy day. The hill is 100 meters long with a vertical drop of 30 meters. So I'm just going to kind of draw a picture. Here's the pig, which is the mass. They tell me this and they tell me this. So this is 30 meters and this is 100 meters. The pig slips and begins to slide down the hill. What is the pig's speed at the bottom of the hill? Use conservation of energy. So basically we know that using conservation of energy, we know that the total energy before, and this is in layman's terms, is equal to the total energy after. And there's no spring or anything, so we're just going to be looking at potential and kinetic energy. So before, we can say KEI plus PEI is equal to KEF plus PEF. Now before I go on, I'm going to say, okay, what's happening initially? Initially, the pig is up here and he's not moving. So because he's not moving, the kinetic energy is 0. So I can just have that whole term disappear. At the bottom, remember, for potential energy, we always have to have a frame of reference. And our frame of reference, we call it base level, but it's the ground. So when the pig now is down here at the end, the potential energy is 0. So now I see that mghi is equal to 1/2 mvf squared. Okay. Now what I can do is I can cancel my masses. And basically what I'm solving for is I'm solving for VF. So now I'm going to rearrange the equation to solve for the unknown in terms of the known. So how do I do that? Well, I want to solve for VF. So I want it to be in the numerator on one side of the equal sign all by itself. Well, right now it's in the numerator, so I'm not touching it. I'm going to leave it over here. So first I'll get rid of the 2 by multiplying, I'll get rid of the 1/2 by multiplying both sides by 2. So now I have 2 GHI is equal to VF squared. Now the reason we rearrange the equation to solve for the unknown in terms of the known, instead of plugging the numbers in, half of you would forget to take the square root at the end. So that's why when I do it now, when I say the square root of 2 GHI is equal to VF, now I easily substitute in my n numbers 2 times 9.8 meters per second squared times, now here's the thing, the height. This is the part where you have to be careful and look at the information. Remember, when I do conservation of energy, I'm doing the energy here is equal to the energy here. The potential energy here is mass times gravity times height. It's the vertical height, not this. Okay? So this is going to be 30 meters. Remember, when I'm going from here to here, it doesn't matter the path that I take. The energy from here to here is same as the energy from here to here. So then when I do this on my calculator, remember, I want to carry my units through, so I'm going to have meter squared second squared. So when I take the square root of the number, I'm going to have the square root of the unit, and the square root of meter squared second squared is a meter per second, which is the correct unit. And then when I substitute it in my calculator, this comes out to be 588, and then when I take the square root of that, I get 24.2. So VF is equal to 24.2 meters per second. Now, this problem didn't have a picture, but by me drawing a picture like this, I clearly see when I'm using conservation of energy, I'm using the 30 meters and not the 100, the incline. And that's why drawing a picture helps you to conceptualize and you need to draw a picture, and you just clearly write the more you write down on paper, the less likely you are to make a mistake.